Today, we're going to talk about a huge leap forward in AI. We're moving way beyond just having a conversation with a machine. We're talking about AI that can actually do things. This is Agentic AI, and honestly, it's a total game changer.
I mean, we've all been there, right? You're using an AI chatbot to help write an email, maybe summarize a long article, or even spit out some code. It's super useful. This is the kind of AI we've all gotten pretty familiar with. But imagine this for a second. What if instead of the AI just telling you how to do something, it could just go ahead and do it for you? That's the jump we're looking at. We're going from AI that talks to AI that acts.
And this right here is the best way to picture the difference. A standard language model is basically reactive. You give it one prompt, it gives you one response. Simple. But an AI agent, that's proactive. You give it a high-level goal and it goes off, creates a whole multi-step plan, and then actually executes on it.
So what are we really talking about when we say AI agent? Well, here's the textbook definition. But in simple terms, it's a system that can look at a situation, understand what needs to be done, make a plan, and then take action in the real world to get it done. And it doesn't just do it at one shot. It keeps planning and acting over and over until the goal is met. So how in the world does it actually do that? How does an agent think its way through a complex problem? Well, it all boils down to this really cool core process, kind of like its own little thinking loop. And that loop is usually built on something called the REACT pattern. It stands for reason and act. It's super intuitive. First, the agent thinks. It reasons about the problem and breaks it down. Then it acts. It picks a tool and uses it. After that, it observes what happened. And finally, it repeats the whole cycle, using what it just learned to update its plan and figure out the next best step. It's a constant loop of learning and doing. Now, why is this thinking out loud step so important? Well, it's not just for show. Turns out forcing the agent to lay out its reasoning actually and pretty significantly reduces errors. And maybe just as important, it lets us see how it's thinking. We can literally follow its train of thought, which is crucial for trusting these systems. Okay, so for an agent to actually do things in the world and learn from them, it really needs two things. It needs tools, think of these as its hands, and it needs memory, which is basically its brain. Let's break those two down. So, the hands are the agent's toolkit. This is how it interacts with the world. It could be using a search API to find out what's happening right now, pulling up a calculator to do some math, or even accessing a private company database to get sales figures. This is what lets it go beyond its static, pre-trained knowledge. But how does it use these tools without messing up? That's where something called function calling comes in. The best way to think about it is this. Instead of just kind of vaguely asking someone to check on sales, you're handing them a perfectly, precisely filled out order form. The agent doesn't output fuzzy text, it outputs a structured, machine-readable command that a tool can follow perfectly every time. And here's what that looks like in practice. See? It's not just words, it's a structured command. It says exactly which tool to use, the database query one, and the exact parameters to use with it, like which table to search and how to filter the data. There's no room for misunderstanding. It's clean and it's reliable. All right, now let's talk about the brain, memory. Agents have a few different kinds. There's short-term memory, which is just for the immediate task at hand, kind of like its working clipboard. Then you've got long-term memory, which holds on to persistent knowledge, like key facts about you or your business. And then there's episodic memory, which is really cool. It remembers entire past tasks, so it can actually learn from its past successes and failures. Okay, so we've got the basics down, right? The thinking loop, the tools, the memory. So now let's level up and see how these ideas can be scaled to handle really, really big challenges. We're talking about going from a solo act to a whole team of AI agents working together. So how do you handle a massive goal, like prepare a quarterly business report? Well, you don't try to do it all at once. An agent uses a clever strategy called task decomposition. It's just like a good project manager. It breaks that huge goal down into smaller, bite-sized, manageable steps. This is how you make an impossible problem possible. And you can take that idea even further. Instead of just having one generalist agent trying to do everything, you can set up a multi-agent system. You have one orchestrator agent that acts like the boss, and it delegates each of those smaller tasks to a specialist agent. You have a data analyst agent, a visualization agent, a writer agent. You're basically building an expert AI team on the fly. But what about mistakes? What keeps these agents from going off the rails and giving you a bad answer? Well, this is where one of the most powerful techniques comes into play. self-reflection. Before it delivers its final work, the agent literally pauses and performs an internal quality check. It asks itself, does this look right? Did I make any logical errors here? Could I do better?
And get this. This isn't just some small, tiny improvement. This is a massive deal. Agents that use self-reflection can improve their accuracy by a staggering 10 to 30%. They are literally finding and fixing their own mistakes before you even see them. That's huge.
So all of this sounds incredibly powerful because, well, it is. But that power immediately brings up a really, really important question. How do we make sure we can use these autonomous agents safely and responsibly in the real world? The answer is guardrails. You have to build in some hard-coded rules to keep the agent in check. Things like requiring a human to sign off on big decisions, or restricting the agent so it can only use a pre-approved list of safe tools. You can set budget limits to prevent it from running wild and costing a fortune, and of course build in filters to make sure it doesn't leak sensitive information. And the ultimate safety net, the big one, is what we call human in the loop. For any action that's really high stakes or can't be undone, like, deleting a whole database or sending an email to all your customers, the agent must stop and get approval from a real person. It ensures a human being always has the final say.
Which really brings us to the big final thought here. Agent AI isn't science fiction anymore. It's happening right now, and the technology is moving at a dizzying speed. So the most important question we all have to grapple with is this. As these AI systems get more and more autonomous, how do we build the systems, the guardrails, and the partnerships to make sure they remain what we want them to be, our trusted, effective, and safe partners?